Okay, I was asked to show a solution on this spherical helium balloon problem out of module 13.3. So in order to find the volume of the sphere, okay, we got 4/3 pi r cubed, and you can see that I have the calculator open on the right side just so I can go back and forth, not have to do too much window switching. But it tells us that a balloon that's 8 feet in diameter can lift somebody that's 17 pounds. And we all know that a helium balloon will float. And it kind of makes sense that if I make the diameter bigger, I'll be able to lift a bigger person. And the question is, how big a balloon would it have to be to lift somebody that weighs 136 pounds? Might be about an average size 8th or ninth grader, I guess. So let's find out. The question is, what's the volume of this balloon that's lifting up a 17-pound person? Because we know that as the volume gets bigger, the amount of weight that it could support is a little bit larger. So let's go with 4/3 times 3.14 times r cubed. Now, if it's 8 feet in diameter, then r is 4. So we'll go with 4 cubed. And let's go figure out over here what that volume looks like. So let's use the A over B button, and we'll have a 4 up there and a 3 down there, and then we'll click out and multiply by pi, and multiply that again by 4 to the 3rd power. So we'll use that A to the B button, and we'll put a 3 there. And that tells me that the volume of that balloon is 267.95. 267.95. And that's cubic feet. Now, we can assume that a 267.95 cubic foot balloon can lift a 17-pound person. I guess the question now is, how many balloons would it take to lift a 136-pound person? Well, let's come over here. I'm going to hit enter, and I'm going to divide 136 pounds. Each balloon, apparently, that's this size could lift 17 pounds. So let's go ahead and divide that. What's 136 divided by 17? And it turns out that that's 8. So it would take 8 of these balloons. It would take 8 of these balloons to lift 136 pounds. So let's figure out what the volume of 8 of those balloons was. That's 267.95. I'm going to cut that decimal off. I don't think it'll make too big a deal. Times 8. And that tells me that the volume of this balloon would have to be, in order to lift somebody that big, the total volume of a single balloon would have to be 2,143.6. Well, that's all fine and dandy, but it didn't ask me that question. It asked me what would the diameter be, and I know that the diameter comes from the radius, and that's the only thing I need to find the volume. So we're going to reverse engineer a volume formula here. So we know that V equals 4/3 times pi r cubed. And the question is, what's r? I know my volume. My volume is 2,143.6. And that equals 4/3 times 3.14 times r cubed. And you're right to have a question on this problem, because we haven't really solved anything that looks like that before. Well, let's get r cubed by itself. We got a couple of steps. The first thing I'm going to do is I'm going to get rid of the 4/3, and the way we do that is we multiply by the reciprocal of 4/3. Got a little bit ahead of myself there, which is 3/4. So I'm going to multiply this side by 3/4. But at the same time, I'm going to divide. So that's going to get rid of this. And then I'm going to divide both sides by pi. And I'm going to get rid of that. And if I take a look at that in the calculator, it looks like this. We're going to go A over B, and we'll have 3/4 times that big number, 2,143.6. 43.6. And then we're going to divide that by, and don't worry about where that looks, that's okay, 3.14. And I get an answer of 512.00. And the last thing that we're going to do, so that's r cubed is all that's left on this side. That goes away. And all I'm left with is this, r cubed, which is from the right side, equals 512. And I'm going to just call it 512.00 is fine. I'm going to leave that alone. And the way we undo cubing a number is we take what's called its cube root. And if we come over here to look at the calculator, we're going to need this button right here. So I'm going to hit that with a little n, and I'm going to put a 3 right there. And inside there is 512, and that tells me that the radius would have to be 8 feet. So the radius is 8 feet. Wasn't quite complete. The problem asked, what would the diameter be? And the answer is the diameter has to be 16 feet. So a 16-foot balloon in this example would lift a 137-pound person. And that's how you do that. By the way, if you want to work on your IXL and get that up past about 80, this is the kind of problem that you have to be able to do to reverse engineer a dimension of the sphere. All right, good luck.